Hi everybody, I'm testing something out for the connection. I may have to take the stream down that doesn't work. If you can hear me, type something in the chat, and, like, hi or whatever. Okay, what does the video look like? Is it blurry? Is the resolution low? Because I have a flag here that says poor connection, and I think it's just trying to send too much data. YouTube is warning me that there are serious issues that need attention. And everything looks okay? Okay. Because I have this button that lets me stream, like, with near real-time interaction. So, like, the delay, instead of being 20 seconds, will be, like, 5 or 6 or something like that. But it doesn't support closed captioning. It doesn't support 1440p, and it doesn't support 4K. I don't stream those resolutions anyway. We certainly don't need my lectures in 4K. Just put that right up on your giant-ass TV in your living room and kick back with some popcorn. I'll just let it ride. We'll see how this works out. But it is a little bit early, so we'll get started in about 2 minutes. You will need to have a way to reference Lab Worksheet number 2. So go to Canvas and grab that if you can. See you in a bit. Actually, now that I'm thinking about it, what quality is it streaming to you guys in? So if you click the little gear at the bottom of the window, it'll say quality. If somebody can tell me what that is, let me know. Oh, I actually have people getting 1080p. Okay, that's what I'm streaming in. I have this little tiny preview window, and it told me 360, and I was worried. Because I definitely don't want to stream in 360. But it's a preview window, so I don't know. Oh, I gotta get water. I told you guys to do that, and I didn't do it. I'll be right back. Alright, so we're going to give this a try. If you're just joining us, I'm streaming in ultra-low latency mode, which means that if you ask me a question, I should be able to get back to you much more quickly. I do have this flag on my live stream window that says poor connection, because I'm probably sending a lot of data. Or maybe my internet's just being crappy, I don't know. It seems to be okay. If there are issues with the stream, please type them in the chat so I know. I can take it down, toggle the mode back, and then put it back up, and then we can continue. It'll just be 2 videos in the playlist later on when we get to that point. I gotta find what I was looking for. That's this, I believe. All right, so today is a lab lecture day. What that means is that we're going to go over what will be due in the upcoming week for lab worksheet number 2. After that, we're going to talk about lab worksheet number 1 because some people had some questions. And then we'll just do general Q&A, and you can talk about whatever you want. I don't have a tablet, though. That I need to grab from my box. Let me do that real quick. I actually got to draw on my tablet, like actual draw, and not just lecture on it last night. And that was kind of nice. I'm not a very good artist, though. So, okay. So if you navigate to the Canvas page, what you will find now that you have completed all the orientation stuff is that the lab worksheet stuff was available. If you don't see this, you really need to do the orientation lecture. Presumably, you have already accessed all the stuff for lab worksheet 1. Lab worksheet 2 is now available. So I've clicked on these tabs already. So here is lab worksheet number 2. Lab worksheet number 2 involves dealing with moles. Now, we haven't talked about moles yet in class, but we're going to do it tomorrow. The general gist is that the calculations involving moles help you figure out formulas of stuff, kind of like what we were doing in lecture on Tuesday with the, or not Tuesday, but last week, talking about the law of multiple proportions and law of definite proportions and stuff like that. These techniques are going to show strategies to determine solid and aqueous substances in their formulas. It's split into 2 parts. Part A is the solid hydrate. That's going to be the solid that has some water bound to it. And then part B is the titration. We're going to talk about a little bit about both today. I'll get to that in just a second, though. Here's worksheet number 2. I can see that a bunch of people are already accessing it, including Anonymous, Kraken, Beaver, and Otter. I love the little Google animals. They're adorable. Same thing as last week. You need to make your own copy, save it to your space. Then you need to fill it out, download it, and then upload it to Canvas. I see some of you have already done that. Good job. Remember that if you need to resubmit it, you can always do that. It will overwrite the old file. I believe that I have made everything formatted correctly, but there may be some issues. So, for instance, if I clicked on a cell and I was typing into it like this, and then all the text just suddenly I'll just do this. That's my cat typing on the screen or something. Actually, that's slower or something. Okay, so it carriage returned there, which is what we want. Oh, I didn't actually fill the box. That's okay. Text. There we go. Alright, so if I hit enter, you'll see that my entry has taken up 3 lines. Some of the boxes may accidentally have their formatting like this, where the text just scrolls out of the box. If you see that on any cell and you want to fix that, then the way to do that is you click up here where it says text wrapping, and you turn text wrapping on with the middle option. If you type in an answer and it takes up more space than the blue box allows, so 3 lines of text, you've typed too much. Condense your answer down a little bit and be more succinct. You do not need to write an entire essay on each question. This goes for lab number 1, too. I think I got all the formatting hiccups, but just in case I missed one, if that's something that is an issue, let me know. There are a lot more tabs at the bottom, but the pages themselves are a lot shorter. So, for example, this is page 2. This is all you have to do is fill in this table. Make sure that you are answering all the questions, and we'll go over how all this works in just a second. The last thing I want to point out is that the third link in the modules is a link to this page. We're actually going to watch these videos today, but the videos are linked in the modules, and they are also linked in the documentation, though I don't know if you can actually click on a PDF. If the boxes disappear, or the color of the boxes disappear, that's okay. I don't actually need to see the color when I open it in Excel. I just need to have you write in the correct box. I will know where your answer is because the borders are really thick. So let's talk about what the experiment's going to have you do. So the first experiment is a hydrate. Man, their intro is fancy. And I actually want to mute this guy. So what this guy's going to do is he's going to take a sample of this blue powder right here on the left. This is copper chloride hydrate. Now, the formula isn't known. We are giving you a chemical with a formula that is unknown. Your job is to figure out what X, Y, and then there's the Z here that you can barely see because this guy is really sloppy. For data tables, anytime you write a number in a data table, it has to have a unit in it somewhere. However, if there is a unit in the row, like it says volume of distillate milliliters, then you just type in numbers into the data table. Because what that implies is that everything in that row is milliliters. And I try to put the units in there too, because I know that if you start putting in grams, it starts formatting the numbers weird and shoving them all to the left. And I don't want to deal with that. So, all right, so you're going to be solving for X, Y, and Z in this lab. And the way that you're going to do that is you got to figure out how much copper's in your sample, how much chloride's in your sample, and how much water's in your sample. And the general gist of that, I guess I'll just write this down. So let me see here. Here's how that's going to work. If I can find Photoshop on my taskbar. Here we go. There we go. I should be able to undo now if I do this, right? Okay. All right, so you have a sample that contains copper, chloride, and water. And it's going to have some mass to it. So the first thing that is going to happen in the experiment in the data that we provide you oh, I barely didn't fit it on there, darn it. Okay. Is that you're going to heat and dehydrate the sample. Now, what does it mean to dehydrate something? If I heat this up, which part of my formula here is just going to disappear? Oops. People are answering, and it's behind my window, and I can't see it. Yeah, it's going to be the water. So if I heat and dehydrate the sample, I will drive off the water. I thought I chose blue for that. That's the sketch color. There we go. So we're going to drive off the H2O. So what that means is that after this step, we have lost H2O. And then what's left is just this. Hold on. Undo, undo. So now we have just the copper and the chlorine left. And then step 2 is going to be to recover the copper by oxidizing aluminum wire, basically. So we're going to put something into the solution that has this in here. The copper will precipitate out. We can then recover it. So that means that we have this once it's been recovered. And now you might be asking yourself, well, wait a second, what do I do about this? And the answer is right, I got to use my undo function. So whatever is unaccounted for, must be chlorine. So in other words, you're going to have a mass up here at the top. Oh, I went off the screen. I'm sorry. Hold on. In other words, you're going to have a mass on the top here. This is going to be the mass of your compound. Once you drive off the water, only this is left. And then once you recover the copper, whatever isn't accounted for must be chlorine. So you're going to recover one thing and then determine what is driven off the other thing. And the difference must be the third thing. And the way you're going to do that is you're just going to weigh stuff all the time. And so that's what this video is going to show. I got to actually get the video. There it is. All right, so to start, this guy's going to use this crucible, and he's going to write down the mass of it. And I've already done this for you. I've provided you with the mass. And then what he's going to do is he's going to scoop a bunch of it in there. Note what color the compound is right now, because that won't be the same later. We're going to speed this up, because we don't need to see him weighing stuff out. And then once he has the amount that he has weighed out, he'll note it down. So from here, you could determine how much powder was put in there. He didn't just weigh out 1 gram by hitting tare. He's going to figure it out by difference. And the reason that he's going to do that is because this is a more accurate way of doing these calculations. If you transfer something from one place to another, you'll lose some material along the way. So weighing the container empty and then weighing it full will give you the amount that's in the container by subtraction. All right, so there's the sample. That's what we're going to heat. So to drive off the water, we're going to heat the heck out of it. So there it is again. Turn on the Bunsen burner. They get better Bunsen burners because I don't know. They have to deal with those little striker things, though, and that's obnoxious. And so the way you do this is you set it underneath your crucible, which is sitting on a clay triangle right here. I like to have the flame kind of moving around. If you leave it in one spot, it'll cook, but he has it far enough away. And here's what the result looks like. Now, if you look carefully, you can barely see inside that it looks kind of greenish. On the outside is tan. Tan is the target color when it's done. But the greenish blue is, hey, that stuff is still hydrated. So what he's going to do, he's going to break that up, and we'll speed through that. He's going to heat it a little bit more. There's the nearly finished result. And then he's going to crunch it a little bit more. Sorry, this guy doesn't know how to do any camera work. This isn't me, by the way. My hands aren't that freckled. And you can see right there, well, you could see right there if I'd paused it in time. There you go. You can see right there that it's not quite done. There's just a little bit of green left. So if he goes and weighs it right now, he's going to have a little bit of water still in the sample. And I believe he does weigh it right now. So here's what the sample weighs now. You'll notice that the mass went down relative to where it started. The reason for that is because we drove off the water. Some small amount of water was in here. It's now gone. So the mass went down. How much water was driven off? Well, whatever this mass is, and whatever the mass was before, you could do subtraction and find the amount of water in grams. Now, this guy is going to heat it a second time, and he does it off camera. So there he's heated it a second time. And the mass went down very slightly relative to what he had written down the first time. So he's going to write this down as the final mass of the dehydrated compound. I have already done that for you on the worksheet. So assume that I did one drying, and I gave you the mass, and that mass is shown in the data tape. Now, once you've done this, you have just copper and chloride ionic compound in your container, and it's brown. So that was part 1 of the experiment. Let's do part 2. This is just a beaker. That is a label right there that's blue. He's going to pour the contents of this into the beaker. The crucible is this ceramic container right here. All right, so this is something that's interesting. When we put the brown powder back into water, so like it was hydrated, it had water loosely bound to its ionic compound. If we put water back in here, look what happens. Now, this is actually one of the questions I'm going to ask you in the lab, so I'm going to be kind of mum about it. But why did it turn back to the color it was before? And you can answer that in the lab. Of course, if you answer it right now, I can't tell you if it's right or wrong. So if it's wrong and you tell everybody else the wrong answer, be careful. Anyway, what he's doing now is there was a little powder that was in the crucible over here. So he's going to add water to that. Put on a glove because it's probably still hot. It's not hot, dude. It's fine. And he's going to add that here just to make sure that he got all the copper. Because it doesn't matter how much water we have. We just want to make sure every last little bit of copper is in this container because we're going to precipitate it out. And the way that works is by adding an aluminum wire. So, oh, I wish he had shown that a little bit better. So here's our aluminum wire here. And what's happening here? Oh, I can't tell you. I can't tell you the answer. I want you to think about it and then write it as your answer in the lab report because it's one of the questions. What this aluminum does, this aluminum is reactive when exposed to copper ions. This is what's known as an oxidation reaction. Oxidation reduction reaction, I should say, specifically. When you combine metals and ions together, reactions will go... No, I can't tell you. I'm sorry. Reactions will go in a specific direction. This is the premise of how batteries work, is through oxidation reduction reactions. Electrons get passed from one thing to another. What's happening here is that the wire is going to give its electrons to copper, which will cause it to precipitate. So he's going to twist it up, put it in there, and I believe he's going to time-lapse this, but you can see... Oh, he's just putting more wire in, okay. You can see that it's starting to bubble and fizz a little bit. Yeah, zoom it in there so we can see. There we go. And so what's happening here is that the aluminum is reacting with the copper in the solution to make copper metal. And you can kind of see it plating out on the sides here. Now, the reaction is done, and this is a hint to the question that I won't answer for you. The reaction is done when all of the color is gone. All the color of the solution. So if I fast forward, this is the end result. You can see the copper metal on the wire, and the liquid has become completely colorless. Why might that be? So now what he's going to do is he's going to scrape all of this off onto something that he's weighed. So he weighed some filter paper, and then he's going to weigh the filter paper with the copper on it. I didn't use filter paper in my little experiment on the worksheet. I just gave you the mass of copper at the end. But first we got to get it off. So here is the filter paper. We're going to put it into a filter because that's why it's called filter paper. Obviously, it's not going to work like that, dude. Oh, he didn't actually fold it the recommended way. That's okay. You can see that I've tabbed through this very quickly. The reason that we're not going to weigh the wires before and after precipitation is because the wires dissolve. So their mass changes. Because the aluminum is part of the reaction, as the aluminum reacts with the copper, the aluminum wire actually deteriorates and then becomes part of the liquid. And so if we weighed it, we would get more copper but less aluminum. And aluminum and copper atoms don't weigh the same thing, so it's not exchanging one for one. So once we scooped this in here, then it's just a matter of scraping the copper off of the aluminum wire. And you use water to do that. He uses a spatula to do this. Very meticulously, apparently. And so the filter that is being used here, the paper will keep the copper on the top, but allow the water to drip through. And this allows him a space to work with so that he can isolate the copper. You can see that's very hot. That is steam that is being given off as the aluminum metal reacts with the, presumably this is HCl. I can't tell you about the color. I can't just give you the answer. Think about the color of the substances that you've seen in the video. And if there are things that have the same color, it's because they're the same thing. More or less. Alright, so he's got all the copper down. Now he's going to go weigh the copper. And once he's weighed the copper, he'll know the mass of the copper. He knows the mass of the water from up here, this experiment. And then you can figure out the chlorine by difference. All right, that's experiment 1. You're going to have a bunch of data, and that data is going to look like this. This is B. Hold on. There you go. There's the experiment data. I have done 2 trials. I've reported my numbers here. And so you're going to use this information to figure out the formula of the unknown hydrate by turning stuff into moles. Because remember, moles is what determines ratios. I will tell you all about moles tomorrow, but we can talk a little bit about it today if you want. It's just I want to officially talk about it tomorrow so that people who are looking for this in the lecture will know where to find it. That's experiment A. Let me go to the questions real quick. Sorry, I was going over them. Let me scroll back up a little bit to the mention about Discord. So this is a really good program to discuss stuff on. It's far better than the discussion boards. There are 2 problems with Discord. One is that you won't be able to inform people that aren't using Discord, so you do have to download something. And 2, it doesn't cross-post to the discussion board, so I won't see it. Because 3, I can't join your Discord group because I have to give you a safe space that you can complain about me, how I'm such a jerk that assigns too much homework or whatever. Let's see here. I got the unit type, I believe. Will quiz number 1 be curved? Yes. So I believe I talked about this yesterday. Quiz number 1 had an issue where some of the questions would mark all of the points off instead of some of the points off, like the matching ones, where you had to like drag stuff in the right category. Canvas doesn't let me do partial credit on that. Why that's a thing, I don't know. So if you were looking at your scores and you're like, I got 0 out of 3, I'm sure I got some of those right. Yeah, you probably did. That's Canvas being stupid. Fun fact, I went and researched that issue and thought surely they've come up with a solution by now. No, this has been a feature they've requested since 2018. They just haven't gotten around to it. That's my brain exploding sound. So my options are to curve all the scores up, which I'm just going to look at the averages and do that, because I can't grade 72 of these manually for like 1 point each. I'll just give everybody a point. And then in the future, I just will try to avoid using those questions, or types of questions. Do we need hands-on labs for next quarter? Summer quarter will also be online, I have learned. We don't know about fall quarter yet. But not having done this experiment, you will probably be okay in 162. Oh, it doesn't show what you got wrong. Okay, that actually is intended because I don't want you to know your score until everybody's taken it. Or I don't want you to know more detail about the quiz until everyone's taken it. Just because I can't have people say, oh, well, I wrote down these answers and I got these right, so this must be right, so go put that in your quiz. I have randomized the quiz questions somewhat, so you've probably noticed if you take the quiz a second time, you get different questions. But yeah. So yeah, there is some anonymity. I can tell you that I've looked at the average of the students who've taken it, and it's been like 80%. Which is kind of why I'm letting you do it twice, because these issues are going to happen, and presumably on one of your 2 attempts, you will do better, and not necessarily like exactly the same. And yeah, let's talk about experiment 2. Experiment 2 is a titration. Let me put the data on the screen real quick for that. On this, I'm going to do 3 trials. And I have given you this British guy for a video with this really, really annoying riff to intro. So I'm going to play this once, just to... because it plays this like 30 times through the video. Just here it is again, so it can get stuck in your head. And then we're going to mute him. So what he's going to do is he's going to walk you through how to do a titration. So here's all the equipment that is used. We have the chemicals that are going to be used, how to prime and condition all of your glassware, and then how to pipette. So I'm trying to get to the point where it actually starts. I have it written down in the video for timestamp, but I'll just click through here. And obviously, you don't need to watch every last second of this, but get the general gist and be able to answer the questions is what I ask. Oh, now I'm seeing double. Okay, so here's what he is going to do. In the flask, he is going to put a sample of the analyte. The analyte is the sample that you are analyzing. In the burette, he is going to put the titrant. That is the sample that you're titrating. By knowing how much titrant you have before you start the reaction and after you start the reaction, you will know how much was used to a very precise amount. The last thing that he does is he also adds an indicator inside this container, because the reaction is colorless and clear. However, the indicator will turn bright, bright pink when the reaction is done. So what he's doing is he's recorded the amount of NaOH, titrant, at the start of the reaction. Then you open the stopcock and you just kind of let the reaction go and you swirl it around. And this is what you'd be doing in the laboratory. Open it up. Now, if you look really carefully, and I might just be imagining this, you can see where the liquid impacts is a little bit pink. All right, you could definitely see it now. It's right there. And it's very subtle. The reaction is done when the end point is faint pink, and it stays there after you're swirling it. So if it lasts for at least 20-30 seconds, then the reaction is finished. And titrations are a bit of a tease. Like, you think it's done, and then it's not. You think it's done, and then you got to keep going. And then you add too much, and you've over-titrated, and you have to start over. So notice that he's going very slowly here. He's adding 1 to 2 drops at a time. 1, 2, 3, 4 drops. Oh, it looked like it was pink, but it's not done yet. When you get towards the end of this, you want to try and do 1 drop at a time. That wasn't 1 drop, dude. And you'll notice now that it has this very faint pink color. It sort of went away, so we'll add 1 more drop. Oh, he's trying to get it out. Oh, that's too much. And there you go. There's the faint pink end color. You'll notice that there's a white piece of paper underneath. That's to aid in seeing the color. And so we would call that done. Why are you adding more? No, don't do it. Don't do it. No. Oh, over-titrated. I don't know. Maybe he's colorblind. Anyway, you can clearly see it's pink. So now what you do is you go up to your burette and measure the final volume. Burettes count down. So what this number means right here is that I would report 32.60 or something like that, based on where the meniscus is. Also, I'm viewing it from below, so it's a little bit off. But then when I let it drain out, it would go down like this, and then I would measure wherever it ended. Final minus initial is how much I used. So on the lab report form, you're going to see that the volume for final is larger than the volume initial, because I started at 2.86 and then I ended at 14.39. So I must have drained out the amount that's in between. So that's just whatever the difference is. You do that reaction 3 times, and the data I have done is right here. And you can calculate the molarity. If you've taken 140, you already know what molarity is. If you've taken chemistry in high school, you already know what molarity is. If it's been a while, don't worry, we're going to talk about molarity a little bit in tomorrow's lecture, very briefly. Chapter 6 is primarily where we talk about molarity, and Chapter 6 is actually the 3rd chapter we do. But also, the lab documentation tells you how to do this calculation for part 2. If I can find it, and hopefully my table's turned out. Yeah, there we go. And that looks like this. So it'll say, oh, what's molarity? It's moles per liter. Here's how the units cancel, and here's how the calculation goes. I have an equation editor, so if this looks a little bit wonky, I apologize. I didn't make one of these cells merge. That's okay. All right, that's the lab. That's the entire thing that you're going to have to do for week 2. The lab deadline is... when did I set it? I guess we can find that out right now. So let's see. Assignments. I haven't set it yet. Okay, so let's assign that right now, actually. So the deadline will be a week from tomorrow, just like the first lab. So it's due Thursday, May 7th by 11:59. I don't need to put an until date. All right, so if you're in sections OLA and OLB, you should just have gotten an announcement. I have to do that for the other section. Assignment. Lab worksheet number 2. Edit. I do this every time, you guys. It's so obnoxious. Assign to everybody. May 7th. All right, there you go. So those should be posted. They now have a due date. I can even do this. Ooh, announcements before your eyes. Oh, I typed in worksheet. I need to say lab worksheet. There we go. All right, that's it. That's all I got. So the rest of the period will be for going over questions from the first lab. You can also ask questions about the second lab, obviously. I assume nobody has done it yet. And then finally, we'll just talk about general course content if you want. Like, I can't talk about anything on the quiz. I can't do chapter 1 specific questions. So if you ask me how many Monties are there in, like, a box of gold, I'm going to say, I mean, I have 1 Monty, and he's my orc fighter. That is actually my D&D character, Monty. Montgomery Foe Splitter. And then Donovan is one of my Shadowrun characters. So to start off for lab lecture, or for the lab Q&A, I'm going to do this. That's just my tab saver. I play D&D 5e, and I play Shadowrun 5 and 6e. Ooh, that's a good question. Yeah, let me do that. So that is actually an error or issue that I had, and I don't remember when I talked about this. So let me go to Google Sheet number 1. And let's assume, and I'll open this in a new window so it's bigger. So let's assume that you were typing in a number and Google seems to be truncating out your numbers. So let's see here. I don't know if I fixed this. I did fix this. Okay, so by default, what Google does is it does this. So here's what I did. I went to Format, Number, Automatic. And what Automatic does is for whatever a cell I am typing into. So let's suppose I wanted to type this number with that many sig figs. As soon as I hit enter, Google says, oh, all those zeros aren't useful. I don't need them. And it gets rid of them. But maybe you wanted those zeros. So what you have to do is, first of all, you have to go to Format. And then when you pick Number, there's two options. The first one is to pick Number right here, which will give you 2 decimal points. You can choose a custom formatting, which gives you a fixed number of decimal points. The easiest thing to do is to probably just pick plain text. And when you do plain text, whatever number you type in there, it just assumes that it's text and not a number. So any cells that are automatically truncating numbers, highlight all of them, and then turn them into plain text. Some consequences of that do occur. For example, any numbers that you typed, the zeros are lost when it truncates it off. So you got to go back and edit them again. And then the other thing that it does, which is really obnoxious, is it align lefts. For numbers, it's generally better to align right so that the decimals line up for addition. I did not realize that this is something I had to do. So this snippet of information right here is what I was doing to do that. So these are probably formatted. Oh, they're formatted automatic. Oh, I know what I did. I made them text by putting an apostrophe. That's the other thing you can do. If you type an apostrophe, so this, and then type in a number, it treats it as plain text. So whatever you want to do to make your life easier. So that's how you keep digits on the formula sheet. The downside of doing the plain text workaround is that you can't use numbers and formulas because they are treated as text, I believe. Although I guess we could test that. So this is plain text. So we'll do 85.0. We'll do 27.0. And this is just going to be this one minus this one. My formula broke. Hold on. Oh, interesting. It totally works. Okay, so you can use them as formulas. I didn't know that. Of course, you got to also format the answers. Oh, it's going to remove all your sig figs anyway, so. I didn't know that those were a thing. Okay, so I guess I could just do this. Boop. There we go. Problem solved. So you guys are problem solvers. Oh, and there's the same menu that I've just been working with, so. I've been trying to find an Excel analog, and in Excel, that's what you have to do. You have to, like, right-click to format, and then you have to choose general settings and the number or whatever. So I know how to do it in Excel. But yeah, Excel doesn't know what sig figs are, so you're going to have to program it so that you have it spit out the number of sig figs that you want. So yeah, you are going to have to rough your data up a little bit to make it conform to the standards that we want for the assignment. So that was the first question that I got. The second question I got over email was, hey, I have this graph. What the hell do I do with it in terms of like how to read it? So I'm going to make you a graph. So let's see here. I want my data to kind of represent yours. So we're going to say densities are 0.9. That's not 9. 0.95, 1, 1.05, 1.10. And I'm just going to put in some I'm just going to make up some sugar percentages. 2. Uh, 7, and we'll say 11. Okay. That's probably good. So we'll say density and sugar percent. So I want to make a graph out of this. I want this to be on the x-axis and this to be on the y-axis. Actually, that's not the order that I want, so I'm going to move those. Oh, no, it's blue. Let me fix that. Boop. So Google will interpret whatever you put on the left as the x-axis and whatever you put on the right as the y-axis. So if I do this, and I insert a chart, and I want it to be scatter, and... Oh, you can select what you want. Okay, cool. But this is what you want. You want your chart to look like this. Some things that you can do to make your chart a little more readable. For example, I'm not using any of these numbers from 0 to 0.75, so I can just do this. That didn't do what I wanted. Maybe I gotta actually put in the whole thing. Oh, 2.5. I don't know what horizontal means. That's my problem. So 0. This one's fine. God, I hate this. I mix up horizontal and vertical. I'm sorry, I'm an idiot. So 0.75. That's still too low. So 0.85. There we go. That's a lot better. And then I'll just do 1.16. Because that last dot up there is a little bit lost. So we'll do 1.2. There you go. You can play with it, is the thing. So here's our graph. It looks pretty good, actually. I just made up numbers, so I wasn't expecting much. Let me put the line of best fit on here. So we do that by clicking on, it's in series, trend line, and I want to label it with an equation, and I want to show R squared. All right. So what this means is that this is the equation of our line. So our line has this equation. Y equals 0.0182 times x plus 0.911. And then there's this value here, R squared 0.982. We're going to talk about R squared a little bit more in the Beer's Law lab. For now, all you really need to know about R squared is that the closer it is to 1, the more your data looks like a line. And what I can actually do to show that is I can take this data point right here, and I'm going to pull it off the line. And you can see that my R squared went down, because now my data isn't as linear. It's got more error in it. But if I put it back, the R squared will go up. And I could even show... I'm going to copy this and put it down here, just because what I'm going to do is I'm going to say that this one's 0, this one's 5, this one's 1. There we go. So now, if I take my graph and I zoom out so that you can see all the data, I mean, that's what I want. Where is my... Oh, customize. I did it again. I don't know what my axes are. Okay. So here's my data, and you can see that there's almost no line that I can put through it that works. So my R squared is actually 0. So a 0 R squared means that your data isn't linear. There's no line that you can put through it that best describes it. R squared equals 1 means that your data is a perfect line. Only one line goes through all the data. And if you're somewhere in between, what that means is you have some deviation or error that makes your data sort of linear, but not quite. So let's put this back. We can get rid of this. And so here's my graph again. Can I edit this from here? Yeah. And so you might be asking yourself, well, what do I do with this? So you have your equation right here, and you know what the y-axis is. So y is density. And you also know what the x-axis is. That's sugar. Is it that bad if your R squared isn't 1? No, actually, you're never going to have an R squared of 1 because it's impossible to have perfect data. So me just making up data points and getting 0.982 is pretty good. That means you have this is a percent, really. So you have a 98% correlation. If you had 0.99 or something for R squared, you had a 99% correlation. And that's really good, especially in science. If you have a correlation that's like 90 or better, you have a strong correlation. So knowing what my sugar percentage is, I could input it into this formula, do all the math, and it would spit out the density. Likewise, if I knew what the density of the solution was, I could put it in as y, subtract this number, divide by this number, and I would get x. Now, some people are getting equations like this. I don't know, something like that. What this means, this is Excel trying to print a number in scientific notation. So if you see something that has an e in it, so if I had like 4 times 10 to the minus 3, what Excel would write that as is this. And if I had 2.52 times 10 to the 6, or 7, I hit 7. What Excel does is it types this. And that is just an Excel thing. Excel is dumb when it comes to exponents, but it is a shorthand so that you don't have to type times 10 to the over and over. So if you see that, that is what your number is being interpreted as. So treat it like that, and then punch that into your calculator. Or you can even write a formula. So what I could do, and this is an advanced Excel trick. So let's suppose that this is my formula right here. So what I can do is I can say, well, this equals y, which also equals 0.0182 times whatever density I put into it, which would be this, plus 0.911. I haven't put a density in here yet, so it's like I had this. But now what I could do is I could type in any, or I'm sorry, this is a sugar percentage. I could type in any sugar percentage I want, and the density will appear. Or what I could just do is just repeat this formula over and over and over again and just do this. And there you go. Now I have a bunch of values. And you can do this for any value. Now, obviously, your sugar percentages in your experiment are gonna be decimal values. So if you sat here just like guessing and testing, then you're gonna have to try for a very long time to get it exactly right. But you can always just do the algebra and then plug in a number into a formula if you want it to just solve for you. Okay, so I'm going to delete all this because this is the master sheet, and I don't want you to have to clear that if you're downloading it right now. But that's the gist of what you need to do for graphs. I think I got all the questions, but if there are more, let me know in the chat. Anything else on Lab 1 is fair game. I'm happy to talk about Lab 1 all day. That's cool. This isn't a quiz. This is more just like a, hey, this is an assignment you get essentially infinite time to work on. Infinite as in it's due tomorrow, but... if there aren't questions about the lab, you can also ask any questions about the class and material if you want. Or we can sit here and stare at the chat. This is the part where I'm trying to like sneak a second window in here that you guys can't see. Is this okay? This is my channel, good. So just in case you were wondering what that was me finding crickets chirping. Maybe this is better. There we go. I mean, you can ask those questions if you want. Yeah. Can you go over exporting it? Sure. Yeah. So what I want you to do is, so to export something, you go to File, you click Download, and then you click Microsoft Excel. It will ask you to save your file to somewhere. Save it to your desktop, save it to a folder, whatever. And then you upload it to Canvas using this right here. So the assignment, there will be a button for you. Let me turn into a student real quick. Where is my button? There it is, Student View. Assignments, Lab Worksheet, and then you just click Submit Assignment, and then it will ask you for a file upload down here. You only need to upload one file. Don't actually add another file. So you click on this, and then you hit Submit, and you're all set. Yeah, it's not hard. Apparently, when I download them from you guys, let me not be a student anymore. I get to download them all at the same time. So this is section C, it looks like. So I've had 3 of them turned in so far. And I just download them all together. Finding the volume of the water, do you just take the mass of the water and divide by the density? Every time I do density, I have to write the formula down, so give me a second. So D is M over V. Oops, I'm hitting buttons on my tablet. V equals M over D. Yeah, so mass divided by density. If you rearrange the equation and the units work out, then you're doing it correctly. So to get units of volume out, mass divided by density would give you units of volume. I'm getting Steam notifications, and every time I see that, I look over to the feed and make sure that that's not popping up. Because I forgot to turn Steam off. Is there a reason why Lab Worksheet 2 empty crucible goes to the hundredths place, but all other measurements go to the thousandths place? Ooh, that could be a typo. Hold on. To answer your question, no, there is not a reason that is like that. I got to get back to that, so hold on. I think what happened was I pasted the data into the form because I write it in the documentation first, and then I paste it into the Google Sheet. My best guess is that I just misformatted something. So, that was part A, trial 2. Yeah, that's a mistake. Okay, so I can fix that really quickly. Oh, you know what I'm going to do? I'm going to do this. Because you guys taught me something today. Boop. Why didn't it work? I'm sad. Oh, that's weird. Oh, I know why. Because I chose plain text afterward. Okay. Yeah. Yeah, if it's a number, it'll totally do that. But now it won't do that because it thinks it's text. How do you increase the decimal point on the word, like, cat? Yeah, it doesn't work. Okay. Yeah, that was a typo. Thanks for catching that. So that should have had a 0. And I believe it does in the lab documentation. When you stare at these things for, like, 30 minutes, like, you can see mistakes. But when you stare at it for, like, 5 hours, those mistakes kind of blur together. So we only have to graph the soda, but not the Pepsi and Diet Coke. Yes, that's correct, actually. Let's talk about that a little bit. When you graph stuff, you only graph standards. The sodas are unknowns, and so you don't graph them. Because you don't know what their percent sugar is. You're trying to solve for it, right? When submitting the lab worksheet, is there a certain way we should name the file? Yes. When you go to the modules, if you go to this document here, it says how to upload completed worksheets. And then at the very bottom, okay, maybe not at the very bottom, in the middle, gotta give it this. You gotta give it a name that is something like this. Obviously, don't use my name or I get credit. Last name space, first name hyphen, whatever class you're in, and then the section, and then the lab number. Yeah, make sure you rename it. If I get a bunch of files that say lab worksheet number 1, copy 37, I won't know who to give a score to. Yeah, you totally can. So if you re-upload, it should overwrite your old file. In fact, I don't even know if Canvas is assigning your name to the files. Like, that would be really brilliant if it knew how to do that. But I've never done this before. So I will find out. If your files are double named, then hooray. I will still ask you to keep naming them that way in case something weird happens. Like, it shouldn't happen, but Canvas is buggy as hell, so. But yeah, you can totally re-upload your file. Just go back. It'll ask you if you want to resubmit a submission. And that is totally fine. Other questions? In part B, Gavin, is that worksheet 1 or 2? Oh, it must be part 1. So the linear fit formula is the formula that you got when you had the graph. Let me find that direction. Let's see here. Let me find specifically what that's referring to. I'm not sure why your questions are going to... I see it right here. I'm even putting that cursor on it. I can hear you, Caitlin. I hear you. Let's see here. Yeah, so this, I believe, is referring to just the graph that you're going to create. Part B, question 1. Yeah, so using the linear fit equation, that is the equation from your graph. So since you have the data for Pepsi and Diet Coke in some capacity here, so like you're measuring something, hint, it's the density, because it's what I'm asking you for. You can use the density to calculate the amount of sugar in it by using this linear relationship. Caitlin, are you having issues typing in or sending questions through the chat? It sounds like it's not working. There we go. I see that question. So part A, let me find part A. Can you be more specific? Let me actually go to the worksheet here for that. That's the wrong worksheet. There we go. Oh, so for like right here. Okay, so if you are doing this math here, what you'll need to do is you need to consider sig figs based on what operation you're doing. So for example, if I want the mass of water, that's just going to be the mass of the beaker and water minus the beaker. So that would be a problem like this. And so I would do the subtraction, I do it linearly, and I would use the addition and subtraction rules. But then, when I do the volume of water, I need to multiply that by the density of the water, which I believe I gave you somewhere. Oh, I hope I gave you the density. It better be in the worksheet. Oh, it's right there. Okay, thank goodness. It's like, wow, you can't do anything without that, and nobody's noticed. Okay, cool. So using the density and the mass that you calculated, you could find the actual volume of water. And you're going to get a lot more sig figs that way because you're going to have a mass that has a lot of data and a density that has a lot of data. But your percent error is going to be really weird because you're going to be doing something like this. So maybe like you got 48.374 grams minus 50, which has 2 sig figs. So you do that subtraction for this number, which would actually be... This would be like negative 2, actually, would be the answer for that. And then you would divide it by the volume of water that is calculated, which would be 48.7, or whatever it was. And divide. I might have these numbers flipped around because I'm trying to do this in my head. I like to write everything down. Percent error is experimental minus true divided by true. And I should have given you that formula also. That's not the right one. There it is, right there. Oh, it kind of got chopped off a little bit, but you can still see it. Negative percent sugar, that is possible. That is possible because, not like realistically speaking, like I could not give you a solution that had negative 5% sugar. But experimentally, that is possible because of error. So I have not actually done the calculations. I need to go through and actually write the key for this. But if you get a negative percent sugar, that is not an incorrect answer. So don't immediately discount that. It is possible to have done everything correctly. And then just due to how error worked, because I put some error in here. You'll notice that in the Pepsi example, I gotta find it again. There it is. So in this example right here, this answer is actually lower than the answer that you got because the original label that I took my data from was Cherry Pepsi, which has more sugar in it. So I was modeling my numbers above around that. So you're just going to get a larger number because I was using a different soda. But you didn't know that. And then Diet Coke, I actually just... I knew the answer would be 0 because Diet Coke has no sugar in it. But I wanted you to have some result that wasn't exactly 0. So I just punched in random numbers. Not totally random, but like approximately random. I do want to comment about percent error really quickly. Some students have asked, how do I do a percent error when the true value is 0? And the answer is you kind of can't. The way that percent error works is that it is a scaling factor of how close you are to the correct answer. So like if you were off by 100%, that means your answer is double or half of what the correct answer was. But you can't be double or half of 0. You can't be any multiplicative of 0. Like, you can't be any factor of it. So percent error doesn't really make sense for having something that's 0. In that case, you should just report what your percent sugar was. Or say something to that effect when you're trying to enter that into the box. And that was something I only realized after I typed it in, and I was like, wait a second, you can't do this. But it'll be something for my students to think about, and so that's why I left it. Don't worry too much about that one. That one won't necessarily be super crucial to have an answer for. Other questions, because we are due for a break, but if everybody's done, then we can just call it a day here. Actually, I guess that's what I'll do. So let me put the title card up. So we'll take a break. And I'll just come back in 10 minutes. And if there's more questions, we'll keep going. And if there aren't, I will turn the stream off. And we will all enjoy the wonderful quarantine and look through the doors and miss the wonderful world outside. Yeah, I'm trying to load the timer. There it is. All right. What can I play for 10 minutes? Oh, I know. How about this? I had my headset off. I was on my phone. Let me get rid of this real quick. So I can answer. I know I got 959.99 yesterday too, and I'm really sad about it. So I can answer these questions pretty much just verbally. So how detailed should we be with each question? So what I want you to do is to give the answer and then like once or two sentences to support your answer. Don't write more than that box holds. I realize that box is really big, but some people write a lot. So if I asked you like what is the density of something, then a good answer would be like the density was calculated to be number by using the graph. Whereas a not as good answer would be 7. Generally speaking, I want you to give me a little bit more meat on the answer than just the bare bones. For the actual percent for Diet Coke, how do you report percent error? We did go over that a little bit a while ago, but it's not super important to report any percent error for that problem because it's undefined. You could report just what your answer was, or you could say it's impossible to calculate or something like that. Don't leave it blank is all I ask. Type something in there that shows that you were thinking about it. Anyone else have any other questions? Boop. Boop. I take it as a no. Unless something. I mean, there is Twitch delay, so I'll just or not Twitch delay, but YouTube delay. Yeah, I stream on Twitch sometimes, so. Not often, we'll say. All right, well then I think that will do it for today's lecture. Tomorrow we're going to finish Chapter 2. We're going to talk about moles. I don't think we're going to start Chapter 6. Chapter 6 is the third chapter that we do in the course. We do 6 because it has molarity. So we'll start that next week. Once we are done with Chapter 2, I'm going to rate the Chapter 2 quiz and put it online. So that will be posted over the weekend at some point. Make sure you do worksheet number 1 by the deadline. The deadline is tomorrow at 11:59. Because I'm going to download everything on Friday night. So if you haven't turned it in by Friday night, I can't help you. Unless you use an NQA. Okay? Thanks for watching, and I will see you next mission. Or next class, or whatever.